So my name's Holmes, and I'm going to be talking today about my project Quiet, which is a Slackier signal for organizations and communities doing sensitive work. So let's see. So first, a bit about me. I'm a former co-director and now board member at Fight for the Future. I worked with Evan for a long time. I used to work on campaigns there for online privacy and freedom of expression. But since 2020, I've been working on Quiet, which is a messaging app, but pointed in a similar direction. So the first question I want to get at is like, who needs this? Who needs a Slackier signal? I've been researching the needs of activists, journalists, and security experts who advise activists and journalists since 2020. This year, I've been working super closely with some abortion funds based in the US, a group of climate activists, and a group of, or a Russian language news organization to tailor what we're building to their needs as closely as possible. And what I'm seeing is that many organizations, and this is probably familiar to you too, exist in an uncomfortable place between Signal on the one hand and Slack or some even less secure tool on the other hand. What groups want from Signal is they want the end-to-end encryption, they want time deletion, they want usability and reliability. But once they fit their whole organization into a Signal chat, that chat becomes total chaos. And then once they start splitting across many different chats, they get a whole different kind of chaos where adding and removing members has to happen by hand across many different chats, and things just get disorganized. There's also no history or context for new members who join, which is really bad for organizations that are, integrating volunteers or that need to read people into the conversation often, read new people into the conversation. So what should they switch to? The thing is, there's not like a super clear answer. Mattermost, which is a self-hosted Slack alternative, doesn't have end-to-end encryption. And you have to deploy your own mobile apps if you're self-hosting. And Matrix doesn't have user-defined disappearing messages. They have to be set at an admin level, last I checked. And the onboarding is confusing, especially for self-hosted users, because you have to choose home servers and stuff like that. So those are barriers we see to using those tools. And if we think about what features a Slackier signal would need, well, it would have signal security and privacy, like end-to-end encryption, time deletion, and a lot of attention paid to what data the server retains. Signal has put a lot of thought into the subpoenaed server threat model, which is important to many of our users or potential users. And it would also have Slack's context and organization. So things like channels and threads, history, and team level access control. So you have a sense of who's in the team, who's not. And those features present an interesting contradiction. On the one hand, we want to limit what the server retains. And on the other hand, we want new users to have access to all of the history messages in the team. So is there a way we can have both? The first solution we pursued is to build something that's entirely peer-to-peer and local first. Local first software is the idea that you can situate authority in clients and applications running on people's devices instead of on the server.
Interrupt you for a second, but I
Sure.
don't know if we're intending to not be sharing, but I don't think we can currently see your slides.
Oh, I'm sorry. That is an oversight. Okay, here are my slides.
Okay, cool. Yeah, sorry to jump in.
Sorry, I should have checked when we started. Sorry about that. Okay, so everyone can see my slides now.
Yes.
All right. Thanks. Okay, cool. So the first solution we pursued is to build something with that's peer-to-peer and local first. So we situate all authority in clients and use peer-to-peer networks to sync data between those clients. And we use a data structure called the CRDT, or a conflict-free replicated data type, to provide consistency between clients over time. And this is how Quiet works now. We use, let's see, every Quiet community creates its own private peer-to-peer network using libp2p over Tor. Messages sync via OrbitDB, which is an IPFS-based CRDT. And to invite new users, you share an invite link with a Tor onion address and a pre-shared key that gets them into the peer-to-peer network. So it's almost like, the way to picture it is almost like a BitTorrent network, but instead of downloading, a torrent, you're syncing each other's app state with everyone else that's in the community with you. So messages, channels, user profile.
So sorry again. I'm not sure if they go up and then they come down. So I'm not sure if something is closing the slides, but it went away again.
It's on every slide change. Whenever you change the slides go down.
But you're showing
that
up like
is
a big brother.
that is wild. Hold on. What about when I do this?
Okay, that works.
And when I click away, I still have it.
You can still see
Can you
it.
try advancing the slide?
And I can advance the slides.
Yeah.
That works.
All right. Oh, sorry about that. Yeah, it's something about how Zoom was interacting with full screen, I think. Sorry about that. So, all right. So, okay. So that's what we're doing now in Quiet, but a peer-to-peer network has these major limitations. What if nobody's online? Where does your message go? Getting Android notifications to work costs some battery life because peer-to-peer clients have to stay online. iOS notifications are totally impossible with a peer-to-peer app. You need some kind of server to deliver iOS push notifications. And there's a pretty strict memory limit even just for like fetching iOS notifications. So you probably can't do that with a peer-to-peer network either. So let's see. So the solution we're pursuing now is to add a server for ephemeral storage where clients can send the server their state updates and they encrypt everything before sending to the server, but they include a TTL or like an expiration time so that the server can delete all data as soon as the clients want them to. And this also lets us help with delivering push notifications to mobile users. So mobile users can optionally register to receive push notifications. They can circulate tokens to other members so that other members can notify them. And the server can deliver empty push notifications to Apple and Google that basically just tell people's devices to wake up. Then mobile apps fetch the data from the server and display it to the user. So this is really cool because it gives us and our users some control and flexibility over how data is stored on the server. And we can play around with the cost benefit trade-offs of retaining data on the server versus making it ephemeral. And also things like switching servers is super easy because the authority is in the clients, and monitoring your server is really easy too. And it'll be easy for users to run their own server, but we're going to offer one ourselves. So the next thing we have to figure out is message layer encryption. Users of a Slackier signal need things like direct messages, private channels, roles, support for multiple devices, and of course the ability to remove users. So there's a question of how that will all work in a local first and peer-to-peer context. The first question is, do we use the message layer security standard? And it doesn't quite give us everything we need. The best model I've found out there for building collaborative local first apps with end-to-end encryption is a library called local first web/auth. And like MLS, it updates group membership by creating a new secret and encrypting that secret to all members. But it goes a bit farther, and it actually stores all membership changes and all your linked devices and all of the roles in the organization in a graph of signed hash-linked entries so that when there's an update, it can traverse that graph to see what devices need to have their keys rotated. Or what devices need to receive the key to the conversation going forward. And when you invite users, you share a token that gives them access, or that lets them, that they can add to that graph to prove that they were invited. So there's a question about internal metadata privacy, which is tricky. Like, you don't want others in the organization even to necessarily know who's talking. So there are some different options. If you sync encrypted messages with everyone, that's great for availability, but it reveals metadata to other members potentially. If you only sync with the intended recipients of your private message, that's bad for availability, because what if they're not online at the same time as you, or what if the data expires on the server before they get it? And you could use Tor for broadcasting messages to everyone, but doing that right is pretty tricky. So one nice option would be to sync only with the recipients of your message if they're online, but otherwise you share it with everyone. And another option would be to use the server only for private chats, and we could give users those options. And finally, or not finally, but another big problem with, or big problem to solve with at the message layer encryption level is user removal. So the way we're thinking this will work is that peers would respond to removal requests by authorized users. And to prevent future access to the clear text of messages, you can rotate keys, okay? But then you also have to revoke access to like get the data itself on the peer-to-peer layer or at the server. So you could rotate the server endpoint or perhaps revoke a certificate. And at the peer-to-peer layer, we can rotate the pre-shared key for the peer-to-peer network and kind of tear down the peer-to-peer network and make a new one. Potentially, we could even rotate onion addresses to remove people's ability to see when peers are online once they've been removed from a community. There's sort of the question of how far we need to go there. For account recovery, probably our first approach will be to encourage people to link devices. If you have multiple devices and lose one, it's easy to recover, and that's the easiest case. Also, in admins of the community, since these are these are sort of team-centered chats, they will be able to re-invite users who lose their devices, but those users would lose private messages. And we might be able to let people restore identity or their DMs with a written down passphrase. Another interesting case is we need some way of suspending accounts. So there are scenarios like arrests or device seizures where community members need the ability to quickly suspend a member's access to messages and then quickly reinstate them in case of a false alarm. So this is a pretty interesting problem, and we've been talking with some folks here about a solution, but I'm interested in others' ideas for solutions to that too. So anyway, my goal with this talk was mostly just to expose a lot of the questions in the problem space that we're in and get a conversation going. So it would be great to switch to the conversation part. I'm going to switch to my final placeholder slide here. Thanks so much for listening. And if you know any organizations who need something like this, it would be great if you could be in touch. I would love to talk with them. And if you'd like to advise on any of the cryptographic or security decisions we're making as part of this process, I would also love to talk with you. And this is my email.